Hi girls, how are you? I just wanted to do one more video just to help you a little bit with calculating KC. So this is really more the same, to be honest, from yesterday, but it's just a little bit, like I said, there's a lot of variation within these questions. It's not probably as formulaic or as consistent maybe as some of the like heats of reaction questions. So you do need to be able to think on your feet a little bit about what goes where and what they're asking and what they're giving you and stuff like that. So this is a good example of a slight variation on what we've done before. This is question from page 393 of your textbook, question 10. Excuse me, I was running out of exam questions from the papers and I wanted to leave you a couple to do, so that's why I picked one from the book here. And you should definitely try the other questions on that page after this. In fact, that's a good place to start if you're new to this, which I imagine most of you are. So what we're going to do is we're going to look at question 10 from page 393. That's what this is. And you're given this equation here. You've got CoCl2, and it produces carbon monoxide and chlorine. And you're told that initially, you see what I've done? I've already made my table here. Can you see that? Initially, we've got 4 moles of CoCl2. And the difference here is that you're told how much CoCl2 is left. So you're not given the amount of the product at equilibrium. Instead, you're given the amount of reactant at equilibrium, okay? So just look at that, stop the video if you don't believe me, and look at the question and see what you're told, because you're told the amount of CoCl2 that's left, which is 1.6 moles. So you can see what box that's going into, can't you? That's the one that's going in of CoCl2 at equilibrium. That's the most important part of this question, and that's what's different about it, and that's where you're likely to trip up if you do. Okay, so if that's what's left at equilibrium, how much has been used up? Well, it has to be whatever the difference is between what's left and what was there at the start, which is 4 minus 1.6, which is 2.4 moles. Okay, so what gets used up there is 2.4 moles, right? Now, if 2.4 moles of this gets used, as you can see, the molar ratio is 1 is to 1 is to 1. So that means that 2.4 moles of carbon monoxide must be produced and 2.4 moles of chlorine must be produced at equilibrium. So we're going to write in 2.4 there and 2.4 there like that. And obviously we had 0 of those at the start. Okay, so you can see now I've filled in my boxes quite easily, but the key point is where that 1.6 goes with this question. Okay, you've just got to be a little bit careful that you put that in the right place. Okay. It also tells you in this question that it was carried out in a volume of 4 litres. So what we're going to do now is we're going to divide by our volume, which in this case is 4. So I'm going to divide each of these, 1.6 divided by 4, 2.4 divided by 4, and 2.4 divided by 4, like that. And that's going to give me these numbers here, 0.4, 0.6, and 0.6 like that. Okay, so you see what I've done? I've changed from moles to moles per litre by dividing by the volume, 4, which is in the question. Now I've got these 3 values. Now I'm ready to calculate Kc by using my equation. Kc equals Co multiplied by Cl2 divided by the concentration of CoCl2. Those square brackets are really important. Make sure you include them if you're asked to write Kc. Okay, so this is literally these 3 values. I'm going to put them in now. I get 0.6 multiplied by 0.6 divided by that number there, 0.4. And when I put that into my calculator, I get a Kc value of 0.9. All right, so have a go at a couple of these on this page. It's a good place to start, and then have a go at the exam questions that I mentioned in the email yesterday. All right, hope this is going okay. Take care. Bye-bye.